Okay, so today we're going to review another set of skills from grade 9, and that is our study of polynomials. So I'm going to include a bunch of terminology. These are sort of all of the terms that you should have learned about in grade 9, and then I'm going to sort of use these examples over here to illustrate the idea. So the first idea is, of course, this 4x squared is a term, the negative 2 is a term. Note the sign in front always belongs with it. Here we have a term 4x squared plus 6 negative 5x, and x to the 3. So those individually are terms. And just looking at these words down here, of course, this particular polynomial has two terms, so it's a binomial, okay? A monomial would obviously be one term, a trinomial would be three terms, and then anything more than three, so this one over here, it has four terms, it's actually called a polynomial. Okay, let's move down the list a little bit. So then there's such thing as coefficients and constants. So remember that the term is 4x squared. Okay, if the term is 4x squared, then the 4 is what is called the coefficient of the term. And then these terms over here, the negative 2, is just a constant term, okay, because it doesn't actually have any variables attached to it, so it's considered a constant. Okay, so hopefully that makes sense to you. Okay, now let's talk about the degree, okay, and that's something that we didn't emphasize very much in grade 9, but it becomes a little bit more important in grade 10. So when we talk about the degree of a term, the degree of this term right here is 2, because the exponent on the x is the 2. So just like we did talk about quadratics being of degree 2, okay, this constant term doesn't have a degree. Okay, this degree is 2, doesn't have a degree of 1, and degree of 3. Now, when we talk about the degree of an actual polynomial altogether, okay, the degree is actually the highest exponent that you see. Not all of them added up together, but just the highest exponent that you see. So this polynomial is degree 2. And this polynomial is degree 3. Okay, and the other thing that goes along with that is it is proper to write polynomials in order of descending powers. Okay, so this first example is actually already in order of degree or in order of descending powers. So you've got your x squared term first, then if you did have an x squared then if you did have an x term, it would be in the middle, and the constant term at the end. So this one on purpose is not in order. It's not in descending order, which is the proper order. Obviously, we could write things in what's called ascending order, but the proper way to write polynomials is in descending order of powers. So what I want to do with this example is I just want to rewrite it in what is called descending order for you. Remember that, of course, the sign in front of the term belongs with it. So if I was going to write it in descending order, I would have x cubed, then I would have my plus 4x squared, then I would have my minus 5x, and my plus 6. And that is the proper way to write polynomials. Okay, so as we're going through this, make sure you're using the proper terminology and make sure you remember the definitions of those. You can always look them up online or in your textbook if you need any help with that. Okay, so the next thing that we're going to review from is simplifying of polynomials. Okay, so most of the questions you'll recall say simplify or expand and simplify. Okay, and hopefully you remember what that means. Okay, so our first example is fairly straightforward. There's actually no reason for this to be in brackets. I just set it up in brackets for you so you could recall the idea of collecting like terms. Okay, so hopefully you remember that like terms have the same variables and same exponents. Okay, so to remind you here, we have our 3x squared and our 4x squared, which are like terms. Our 7x and our negative 8x are like terms. And our constants, our negative 7 and our 8 are like terms. So you will recall last year in grade 9 that you probably rewrote this without the brackets and perhaps with the like terms together. And since we're just adding those two brackets, you really don't need those at all. So I'm just going to rewrite it with the like terms beside each other. Okay. And then we added or subtracted the like terms. And remember, we can only add or subtract terms if they are like. And once they are like, we simply add the coefficients, the 3 plus the 4. And I always like to think of it as we have like 3 apples, we have 4 apples, and when we add them together, we of course get 7 of those same apples, right? It doesn't change. So we're essentially adding the coefficients together. Okay, in our second set of like terms here, we have plus 7 minus 8, so we end up with negative 1 or minus 1x. Of course, we don't need to write that. I'll show you in a second what the answer would look like in the back of the book. And then we look at our constant terms. We have negative 7 plus 8, and that, of course, ends up as positive 1. Okay, so like I said, in the back of the book, you would not see that 1 there. You would just see it like that. Okay, and that is your final answer. Now that you are in grade 10, I do hope that you can do this part in your head, the adding and subtracting of like terms, so that step is no longer necessary, and you are welcome to go straight to this step right here. Okay, so let's take this a little bit further. Hopefully from last year you remember the idea of distributing, the distributive property, where I take the term in front of the brackets and it gets multiplied by all of the terms in the brackets. Okay, so our first step here is called expand. So we take our 4x times our x, and we get 4x squared. So obviously this is multiplying powers, which we reviewed yesterday. This uses that idea. Then I take the 4x times the 2, and that gives me 8x. And then I take the negative 2y times the x. So I get negative 2yx. And with terms like that, it's actually proper to write them in alphabetical order, the variables. So this is the same as negative 2xy, okay? And it would be proper to write it like that. And our last multiplication here, is negative 2y times negative x squared, which is going to give me positive 2yx squared. Okay, and then we do want to look and see if we have any like terms, and we actually don't have any like terms in this particular case. They all have different variables and different combinations of exponents, so you don't really need to do anything. And because we do have a mix of x and y's here, there's not really a proper descending order or descending order of powers, so you can just leave the answer like that. Again, note that this term is the same as 2x squared y, right? When we're multiplying, it doesn't matter the order that you write them down in. Okay, so let's try a couple more of these just to make sure we get that idea. So these are all expanding and simplifying. We're using the distributive property, and then we're collecting like terms just like we do with polynomials. Okay, so always handy to draw in your arrows. Okay, and this example, of course, is here to make sure you know that the 2x does not get multiplied by the 3x here because the 3x is not in brackets. So it just gets left alone just like it is. Okay, so let's do some multiplication. First we have 2x times negative x squared, which gives us negative 2x cubed. Then we have 2x times 2x, which gives us positive 4x squared. And then we have 2x times negative 4, which gives us negative 8x. And then we just have that plus 3x that we tack on the end there. Okay, so you'll notice in this example we do have a couple like terms here, so then you would need another line where you collect the like terms, and this one actually already is in order of descending power because we have our cubed term first, we have our squared term second, and then just our x terms last. So it actually already is in descending order of power, but you could definitely move that if you needed to. So these two are just on their own. They don't have any like terms with them. And then we have negative 8x plus 3x gives us negative 5x. Okay, now one thing you can do when we are doing the flipped classroom is I would ask you to pause the video right now, and perhaps you could try number 4 on your own and then play the video when you're done to see if you did do it right. So I would encourage you to do that. That's one thing that would help you out a lot if sometimes you feel like you're not getting much out of these flip videos. Okay, first step, draw your arrows in. I highly encourage you to draw the arrows. They help people to avoid making silly mistakes. Okay, and we're going to expand first. And then at the end we get plus 10x squared. And then we're going to put our like terms together, and this is what I was saying, that you don't really need to write them next to each other anymore if you can get away with it now that you're in grade 10. So these two are like, nothing else is like. You can reorder it all at the same time, or you can do that in a second step. It's up to you. So I'm going to get 8x squared minus 3x minus 2x cubed. If I put it in order of descending powers, which a textbook I believe always will, okay, it will end up looking like this. And that would be your final answer. It makes it a little bit easier for you to check too if you always put it in order of descending powers. Okay, so hopefully a lot of that is familiar to you from last year, and we'll be spending the whole period tomorrow practicing that idea, so you'll have lots of time to answer questions and get through some of that work. Thanks for listening.